Hey guys, here I am back again. This is my idea of, instead of using a PWM and all that stuff, which is extremely complicated, this is probably the simplest method that I can think of to produce pulsating or a high energy pulsating DC from straight DC. What it is just a simple flip-flop, transistor flip-flop. It's a DC to AC converter. The transformer, in this particular case, and the one that I'm going to be using, come out of a old microwave oven. And what I've done is I've reversed it, and I'm using the secondary as the input to the transformer. I removed the secondary and I put about 12 turns of number 22 gauge wire. I put 12 turns and then center tapped it, and then 12 more turns. So I got 24 turns with a center tap on my transformer. The primary is the original primary that was on the transformer to start with. The diodes are 2N or 1N 007s, silicon rectifiers, R1 and R2 are 5-watt wire wound resistors. R3 and R4, which makes up R3 and R4, and C2 and C1 make up the timing circuit for the flip-flop. These are 1-watt transistors, and the capacitors, these condensers here, have to be mylar. Use mylar or tantalum. Use a mylar condenser or a tantalum condenser. In this case, it's 47 microfarad is what I'm using. Tantalum capacitors. If you use an electrolytic, they're going to burn up and they're going to explode. Don't use electrolytics for the timing capacitor. The transistors are 2N 3055s. They're very inexpensive. They're about $1.50 a piece, $2. They're good for about 15 amps. And this little circuit that I'm showing you here is good for about 300 watts. So don't get across it, or I guarantee it's going to knock your knickers off. It will definitely put a hurting on you. So this is my answer to the PWM. Now, what I've done with the RC timing circuit here, instead of using a fixed resistor, I've used a variable resistor. And you can switch in other capacitors in here to make the frequency go higher. Of course, if the frequency gets too high, then the core of the transformer is going to saturate, and all it's going to do is just burn up the, it's just going to end up burning up the transistors. Once you've saturated the core, it won't take any more energy coming through it. Now, if you want a higher voltage output, go find a 240 volt transformer. And just remember running it backwards, a 240 volt. Now, when you rewind the secondary, like I said, that's 24 turns of number 22 is what I'm using. But you can use the heavier wire for a heavier amount of current. Like I said, this was only good for about 300 watts. You can use a much heavier wires. This is only 24 turns with a center tap. Extremely simple. Get away from all of that complicated digital doo-doo. And let's go back to doing something simple like transistors. Geez, those things were around for a long time, and they worked extremely well. And you probably even use FETs for this if you wanted to. If you wanted to use a power FET, you could probably use a power FET. It's a very extremely simple circuit. It's just a flip-flop. And like I said, 24 turns with a center tap on an old microwave oven transformer. You pull off the secondary and you rewind it with 24 turns and a center tap at 12 turns. So that's my idea on how to get higher voltage, a lot less complicated than using this PWM stuff, which is cool, but I think this is this is very good for our use. Okay, just my idea. There it is. Extremely simple. I'm going to publish on the I'll give you the values of the components on the sidebar there. So there you go, guys. I don't know what this is going to do, but we're going to give it a shot. This is a very simple way to go at getting high voltage and a substantial amount of power to your cells. Thanks. See you. Bye.